This is section 2.5 on the inverse of a matrix. And the inverse of a matrix is comparable to the reciprocal in regular numbers. In other words, if we had 1 over 3, the reciprocal of that is 3 over 1. And any time you multiply a number by its reciprocal, what do we get? We get 1. Well, with matrices, if you multiply a matrix by its inverse, you get what's called the identity matrix. So we need to talk a little bit about what the identity matrix looks like and what it is. So an identity matrix has a diagonal of 1s, 0 on the either side of that line. So the same thing. This is an I2, which means it's a 2 by 2 matrix, and that's the identity. Identity 3 by 3. So it's real easy to do these on the calculator. You can hit second matrix, use the cursor and select the matrix you want, so you get, say, A on your screen, and then you go to the inverse key, which is X with the -1 up here, and press enter, and you will get the matrix of the inverse of the matrix stored in A. So it's really easy. And we're going to look at some problems, and then and we'll try that on our calculator. So if we go to section 2.5, and I'll do some of these with you, but really I think it will be quite evident of what you're supposed to do. So this says decide whether A and B are inverses of each other. So the easiest way to do that would be to go here and let's clear this, and let's go put this in matrix A. So we'll go to second matrix and over to edit and enter, and we have a 2 by 2. So let's put in 2, -2, -1, and 3. So we've got that. So we're going to second quit, and now we're going to go get the name of that matrix. Second matrix, grab A. And we want to come here to the X to the -1, and it is the key that is under matrix, so we're going to hit that. So what we're telling the calculator is we want to do the inverse of matrix A. So let's hit enter, and we get 0.75, 0.5, 0.25, and 0.5. Well, that is certainly not what is in B. So we know that these are not inverses of each other. All right, so you would do the same thing with this set, A and B. Put in A, find the inverse of it. Nope, that's not what we have for B. So let's try this one. Find the inverse of the following matrix and check to see that, and you're not really going to have to do that because you are doing this on your calculator. It should be fine. So when we do it, when we go put that in, let's do that together. I've got the answer there, but let's do that together. Second matrix, over to edit. It is a 2 by 2. We're going to put in 6, 4, 4, 7. Always do a second quit out of that. And let's do second, whoops, matrix, grab A, and hit the inverse key and enter, and we get these really large answers, and they want us to simplify that, meaning they really want us to put these in fractions. So hit math and enter on fraction, and we get those answers right there. So when you get these crazy decimals, you'll want to do math and fraction, and you can get the answers that they're expecting you to have in the boxes. All right, let's see what else we have. So number 4, same thing. You're going to find the inverse the same way. You're going to put that in A and then do A inverse, and you should get that. Same thing with 5 and with 6. Now, with 6, you're going to do the same thing. You're going to put this 3 by 3 in, find the inverse of it, change to fractions, but the only thing you're inputting for your answer is the third row. So that's the only thing that's going there. All right. Now, these are saying to use the inverse of the coefficient matrix. We're just going to solve those by using the RREF method that we've talked about. So let's kind of go through that one. So we're going to quit and clear out of that. And we're going to change this, before I do that, we're going to change this to an augmented matrix, 1, 7, negative 31, 2, 7, negative 27. And so this is what? This is a 2 by 3, and we're going to put that in our calculator. All right, so second matrix, over to edit. If I can get up here. All right. So we have a 2 by 3. All right, and we need a 1, a 7, a negative 31, 2, 7, negative 27. All right, second quit, and we want to go back into matrix, over to math, and I'm going to go up because it's quicker to get to where I want to go. We'll go to RREF and enter. Go back in and choose the one that we had, which was A. All right, so we're telling the calculator, do all the work, all the row reduction, and let's solve this. So we're not actually doing it the method that they're asking us to, but we are solving it. And our solution, let me pull this over here, is right here, and it's this far column. We get the identity here and 4, negative 5. So that's your answer that you're going to put there. You do the same thing for number 8 and number 9. Just be careful to remember that you don't have an X term, so you have a 0 for that row right there. And you do the same thing for this one. This is how many rows? 4 rows and 4 by 5. So if you were doing that matrix, let's talk about that. Let's make that. So we have a 1, a negative 2, x, y. It should be. Are they putting W at the end? I think they are. 3 and 0 and 9. And then we have a 0 and a 1y and a negative z and a 1y, a 1w, negative 10, negative 3, 3, negative 3, 4, negative 2, and 2, whoops, sorry, 0, 2, negative 3, 1, negative 9. So we have 1, 2, 3 3 rows and 5 columns. So this goes in as a 4 by 5, and then the RREF, and you should get your answer here. So you'll plug in the values there. So I think that gets you going on using the inverse, finding the inverse and doing some more solving. Okay.